Before we get cracking with the Maya environment setup, I just want to mention that there's a blog post where you can copy a lot of the code shown at learncreategame.com/techart/Maya environment setup. Today we are going to talk about the Maya environment setup for you and your team. And we want to set this up so that you can deliver tools and integrate scripts easily. And in the end, we're also going to automate this setup and add callbacks to manage scene preferences so they're the same across the team, and also add in source control. So what is the Maya environment? Basically, we can define it as variables and paths that you give to Maya so that it knows to look for scripts and other resources in certain places. And we want to do that so that we can put our tools and our framework wherever we want to do. We may want to distribute it through Perforce and have it in a single spot for Maya to consume. So the traditional way to do this is, in the most common way I would probably say, is in Documents, Maya. And if we go back to an older version here, there's a Maya env, and in the scripts folder, there's a user setup mel and a user setup py. So these are files that will execute on Maya startup. I do not like using those files. As a technical artist, as someone who distributes tools to other team members, those team members may have put a bunch of stuff in those files already, and I kind of don't want to deal with whatever's in there and figure out where I need to inject my own stuff. So luckily, there's a better way in Maya. There's a mechanism called modules. You can, if you want to see examples of this, it's in the Maya Autodesk install directory, a folder called modules here, and you can see that Substance uses them, Houdini Engine, other technologies that Autodesk has purchased and put into Maya are also using .mod files to bootstrap their environments into Maya. So this is an isolated way to inject your own paths and variables so that you can work in isolation and kind of make sure that you don't stomp the end user's preferences. So we're gonna manually inject this little mock framework that I made in C code LCG. We basically have one site folder for Maya, and in that there are a couple of keyworded folders: icon, scripts, and shelves. And this is where the Python root is. Basically all the Python code lives inside of here. So this is the Python root package, and then we have a bunch of code inside of here. This lib package is third-party packages that I also want to basically insert for Maya in the Python root. So let's manually set up a modules folder. So we are going to go to the Documents Maya folder, and we're going to create a modules directory in here. You can actually create it on the version level, which is pretty cool. But if you create it here on the sort of global level, no matter what version of Maya people install, this will execute. So modules, and inside of here, we're going to create a new text, and we're going to rename that to lcg.mod. Yes, we want to change that. So now if we edit this guy, let me bring this over there. Make that smaller. So basically the syntax is we want to add, and we give it a name, the module a name, and you also have to give it a version number. I'm just going to say 1.0, and then it's the path. Before actually we add this, let me show you something. So in the script editor here, so there, so you can see there's basically no added script paths. So let's jump back to what we're doing here, and let me just show you that this kind of takes effect immediately. We add this, so that we say C:/code// LCG, what's the name of the folder there, and Maya is the site package. If we save that file right now, and we go back in the script editor and rerun that, we import pymel-util, and we print that, you see immediately it's picked up the script paths of that keyworded folder inside of the Maya site package. The same holds true for the icons. And not the shelf. We're going to use another variable that we're going to add to the mod file. And the scripts folder has also been added to Python path. But we are going to add another custom folder. Same thing with plugins. There's a keyworded folder for plugins. So you can put that if you want more plugins. But we're going to specify another folder for that as well. So that's pretty cool. That took effect immediately. So now let's add in that the Python path we were talking about. So to speed things up, I'm just going to paste that in there. And we're also going to add the third party, the lib folder. All right, and then we're also going to add a custom plugin. So basically the way we're going to automate the creation of this module file is via a Python plugin for Maya. And it's really easy to implement, and we're going to go through that. So we're going to add a custom plugin path to where that plugin is going to live. And it is going to live right there. Okay. And then we're also going to take care of that shelf path getting added to the environment. So there. So now if we save that, so we restarted here, and now we can look at the shelf path because it's been evaluated. So we have an empty there because it doesn't really cause any issues, but we added, like we said, plus equals, so it had no shelf path before, but it doesn't really cause any issues. So there you go. So we have added in all those paths into the mod file, and this is kind of all that we need. So now next, let's automate this, and we're going to go through how to create a plugin for Maya. But before we delete the modules directory, I just want to point out a couple of things. So in our framework here, under the Maya site folder, we had a shelves directory that we added, that shelves path. So there's a shelf living in here, and you can see this is automatically kind of popped up, and we have our shelf button. So now that shelf will auto start with Maya, and you can just continue adding tools to that shelf that way. Another thing we have is the script folder, and I tend to use this to just relegate a bunch of old Mel tools that artists collect, and we can just drop them in and distribute them, and now everybody can use those to like high-end 3D stuff or whatever. This is old stuff that we have written, like UV Toolbox, super old Mel tool, but it's just really easy to have all that stuff kind of in one place. Relegate all the old Mel stuff into one folder and you're done. So now let's get to writing. So we're going to go ahead and delete the modules folder, close down Maya, and now we're going to write that plugin. And we're going to go through the plugin and just walk through the logic of what we want the plugin to do. Because like I said before, we want the plugin to handle writing the mod file that we just created manually. And it's going to write it the path to relative from wherever the plugin is loaded. So let's take a look at that code. So here's the code inside of PyCharm. I would recommend that you go to the website and download the code, and then you can just kind of change what you need to change if you want to just kind of follow along. I'm not going to go through line by line. It's pretty heavily commented throughout as well, so each step kind of but we're going to walk through the logic. So the address there to go to the website to download the code is learncreategame.com/techart/Maya environment setup. So first we have our imports. We're going to use OpenMaya to build a plugin, and we're also going to be using it for those callbacks. We're going to be using the OS module, the sys, inspect for figuring out where we're running the plugin for. We're going to use some PyMel, and we're going to use traceback for error reporting. So here we're declaring a couple of variables outside here for Python root, and this is going to store the save scene callback. This is going to store the open scene callback and new scene callback. This first part right here is to basically declare that you're using Maya Python API 2.0. And here we're gonna initialize the plugin. And this function is executed when you run the command through Mel or Python. But we're just gonna accept here. You can have it do something when you're actually executing the command for the plugin, but the main intent of this is that so the user will go to the plugin manager and load the plugin and browse to it. And when the user loads the plugin, that's when we create the environment and the mod file and all that stuff. And when they unload the plugin, we clean up after ourselves and kind of delete all the variables and the mod file. So here we're gonna initialize the plugin and uninitialize the plugin. And we have two functions, one for loading and one for tearing down what we did during the load phase. So again, it's pretty heavily commented. I'm kind of writing here everything that we're doing, but let's just walk through it. So we're looking at where the plugin was. So here, basically the user has clicked load in the plugin manager. So we look at where we are loading from during the inspect there. And then we're figuring out what the folder path of the plugin is, because we're going to add that also to the environment. So then from that, this whole framework, we are counting on that it's kind of distributed as a whole and that the internal structure remains consistent. So we're figuring out what the Python root should be. Basically, it's this directory right here that we're going to be adding to the Python variable, the Python path. We figure out what the modules directory will be. We're using the pymel command to get the environment variable for where the Maya application, the preference directory is basically. Then we're checking if that modules file exists using os path exists, and if it doesn't exist, we create the modules directory. And then we define the modules file itself. And here we're basically figuring out what the tool root is, where this whole thing is running from, so that we have a path to build kind of other paths, so we can build up that. Remember when we created the .mod file, the first line there, we had that plus sign, name, version, and then where this Maya site folder was located. So we're using the tool root to build up that path. Then we're adding on the Python path that we added, and we also add in the plugin paths. And here I've added another part that it will so if you create subfolders of other plugins, you just get plugin happy after making one like this. So you want to make other ones and you all drop them in here in subdirectories or whatnot. This will dynamically go through all the directories and add any other plugins to the plugin path. So the very, very first time that the mod file is written, the path won't be initialized yet. So we're doing that manually here. We're saying like pymel, put this environment variable in there so that the plugin can be auto-loaded and all that stuff. So any shelf file in the directory will be loaded on the startup. So you can create a character shelf, environment shelf, however many shelves you want, and they're going to be automatically loaded. And then we write the module file to that directory. And then we also check that the Python path is in the sys path. And if it isn't, we append it. And we're also appending that third-party lib library to the Python path. Next, let's do the callbacks. So we have the functions written here, pre-save scene callback and the scene configuration callback, I called it. This is basically when you open a new scene that it ensures that the preferences that you have in this Python is maintained for the team. So we create the callback using this syntax right here. So we have a run function inside that. I'm gonna crack these open after I kind of go through the logic here, which is almost done. And then this is a really weird thing with Maya. If the incremental save feature is turned on in Maya, when the user saves, what Autodesk does is that it remove the file from the system and make a backup version, and then your callback triggers. So if you try to check that file out, it no longer exists in the location that it does, or that it did from the beginning, because they will then put the file back after the incremental thing has been saved off and your command is executed. So there's no way to perforce check it out. So I've basically created a overload function that fixes the behavior. I can make this available on the blog too. It's just you inject a little callback basically. So here is where we source that overload script, and it lives in the scripts directory to basically work correctly for perforce checking out, even if you have incremental save. And then on the teardown is when the user goes in and unloads the plugin. So we remove the callbacks, we remove the syspaths, and then we source the original incremental save scene file from Maya back. So that is kind of the logic of the plugin. Feel free to download that and kind of change things around as you want to. And now let's boot up Maya and give it a whirl. Here we are back in Maya. Quick little addendum. I added a check the very first time we load the plugin and we want to overload that script. The Maya script path isn't yet in the environment. It's part of the modules and it will be there on reboot. But basically, if we just want to source it right away, we gotta kind of do what we did to the plugins. We gotta put it into the environment variable there, Maya script path. So that will be updated on the website, of course, when you get it. So just so you don't get confused, I added that in there. And now we're gonna go ahead and we're gonna test out our plugin. So we basically go to the plugin manager, and so the user would basically just do that, and they would click the browse button and browse to the Python plugin that we just created. So we go to C code LZG, in my case, Python LZG Maya plugin. Click that guy, and now that executed, because what Maya does when you actually select to open something, it actually loads it, which ran that code. And now you can see here we imported the perforce module, and we get a nice printout there, which executable the import happened from. That is in the little video that I made with the framework structure and the little tricky imports. You can basically evaluate which executable is importing the Python module and which Python version of the interpreter. And here you can see which version of Visual Studio that interpreter was compiled with in Maya. And that's when sometimes you get conflicts with perforce PYDs not loading because Maya switched to Visual Studio compiler or whatever. Same thing with PIL or Oracle database. That is kind of a common headache that we have to sort of work around. Now let's quickly verify that the plugin actually created. There it is. So it created the modules with the mod file and everything. And so now it doesn't really matter where this whole framework lives on the hard drive, so you can basically move it elsewhere and the user can just go and load the plugin and it will just build up the paths relative from where that plugin is loading and internally figure out what the tool root folder and everything like that is for our framework. So that is very nice. So that is the plugin loading. I hope this video was helpful. If you think so, just drop me a line below. And next I'm thinking about doing the same thing for Houdini. I've been in Houdini a lot lately, and I'm thinking about switching over, doing more tool building videos and learning videos of Houdini. So I will see you guys in the next one. Thanks.